Hello Algebra 2. This video lesson is about Chapter 3.3, which focuses on systems of linear inequalities as opposed to linear systems. And there are three things out of this chapter that I expect you to know and be able to do on the next exam. You ought to be able to graph one of these. If I give you a graph that I've drawn, you ought to be able to read it and tell me what the system, that's what I mean by name the system, tell me what that system is. And then thirdly, if I give you coordinates of a point, you should be able to tell me whether or not it solves the system. In other words, belongs in the shaded region. You'll see what I mean by shaded regions in a couple of minutes. Or I might ask you to supply a set of coordinates for a point yourself that belong in the shaded region. One way or the other, you should be able to do step 3. Okay, so let's talk about what a linear system of linear inequalities is. First of all, it's based on a linear system, like we've been studying for this most recent exam. But the added element is that you shade one side of each of the lines in the system. Let's get to the specifics about how you draw one of these. First, you draw those boundary lines. Remember, back when we were drawing boundary lines before in shading, you may have to have a dotted boundary line. Second step, once you've shaded one, go on to the next one and shade the other. Make sure that you've identified the proper side to shade for each of the boundary lines. And then lastly, what you're going to find with all of these shadings is some common area among the shadings, some that's been shaded for all of the different boundary lines that are in the system. Usually I'll just give you 2, but you'll remember from the most recent quiz that we had linear systems that had 3 lines in them, and there could be more. So as you build more, it becomes a little more complicated to identify the shaded area that belongs to all of them. Let's look at an example. Starting with 2 boundary lines. The red one and the blue one are represented here. The red one is dotted because the arrow, the inequality symbol, is not underlined. The blue one is solid. Notice I've chosen, just to illustrate the point, that you might get an inequality that's written in slope intercept form like the red, or in standard form like the blue. I could even give you one that's in point slope form. You do shading based on, just as you learned before, deciding whether or not some particular point that you've picked does solve the inequality. So backing up here, I decided to pick 0, 0 and see whether or not 0, 0 solved the inequality. And so 3/4 times 0 is 0. 0 minus 6 is -6. And yes, -6 is less than 0. So 0, 0 is on the correct side. That's the side I shade for the red line. Similarly, I do this for the blue one. And I'm going to try 0, 0 again. 0, in other words 4 times 0, plus 0, in other words 2 times 0. 0 plus 0 is less than 8. So once again, 0 is on the correct side for the blue one. And there it is drawn there. Now, I've had to use a triangle here to shade this area because I don't have the software tools that I'd like for drawing. All of this should be in blue over here. The important point, though, isn't just the red or just the blue. The important point is to focus on the common area. And in this case, the common area becomes almost a purple color here. And it ought to also be this area over here and over here and over here. It's just I don't have the drawing tools to indicate that. But everything in this corner over here and extending infinitely that way and also infinitely that way represents the solution to this system of inequalities. Okay, now it's your turn. Here are 2 boundaries. Go ahead, draw those and shade the proper sides and identify the common region between those 2 shadings. Okay, I know this takes a while, but I'm going to assume that you've done all of that work. I'm going to assume that you've been pausing for a while, you've gone ahead and drawn the boundary lines, and then you've shaded the appropriate sides. I'm going to show you how I've done this. I'll build it in front of you. First, those boundary lines. I've chosen, just to make it easier to represent them to you, to indicate them as separate colors. So the first one's in orange here, the second in blue. Both of them are dotted lines, of course. The shadings. Now, really, this orange ought to continue down here, and it would if I had that ability. And the blue would include this area over here that's white right now. But the important point is the common area, and that's this corner here. And it kind of is bounded on there, on that side and on that side, and it continues infinitely in that direction and down there. But it does not include any of this area, does not include any of this area, does not include any of this area. So these points that are here in the doubly shaded area, those are the solutions to this system. Okay, so that's one of the three concepts in this lesson. The second concept is to work backwards. If I give you the graph showing the system of inequalities, I need you to be able to turn around and tell me what those inequalities are. And I'll build one of these in front of you here. First, I identify those boundary lines. I've first labeled them red and blue to tell them apart easily. And I've just identified at this point the intercept for the one I'm calling the red one. That intercept is here at -4. And I know that I need to find its slope next. I've just indicated it as m now. But I know if I look at it a bit that slope is 2. I rise 2 to go over 1. So now I have most of what I need for that boundary line. Now I just need to know which way to draw the arrow for the inequality. Well, I know that 0, 0 again is in the shaded area to the left side, upper left side of that red line. So now I plug 0, 0 into the story that I have there in red. And I've got 0 on the left, and I've got 2 times 0, in other words 0, -4. Or in other words, I've got -4 on the right. Well, clearly -4 is less than 0. So I draw the arrow that way, which means the arrow should be drawn this way for the entire inequality. So this is the accurate description of this dotted line. Do the same for the blue one. I know that the slope's -1 and the intercept is 4, because I can see here that there's the slope of 4 and the slope going down 1 to go over 1. Which way do I draw the arrow? Well, once again, 0, 0 is clearly, I'm lucky, once again, it's on the shaded side of the blue line too. So I plug 0, 0 in. And this time I notice I need to underline the arrow because this time it's a solid line rather than a dotted line. And the answer is that 0 is less than the information on the right, so my arrow ought to go in the same direction for that inequality. And now I clean this up and just focus on the red and blue inequalities, and that is my system of linear inequalities for the graph that I've been given. Sorry, I don't have one for you to do, but there are some in the homework assignment, so you'll get a chance to do that soon. The homework assignment is coming in just a couple of slides. Before I get there, though, there is a third task that you need to be able to accomplish out of this chapter, and that is to work with ordered pairs. In one case, I give you the ordered pair. In the other case, I ask you to give me the ordered pair. I'll explain 5. So what I did for 5 is I simply plugged 1, 1 into that first inequality. And I found that that's not true, that 2 times 1 minus 1, or in other words, 2 minus 1 is not less than 1. 2 minus 1 is 1, and 1 is the same as 1, it's not less than 1. So no is the answer to 5. Hit the pause button and tell me the answer to 6. Okay, I'm going to assume you did that, and that you found the answer is no once again. And it proved to not to work for, once again, that very first inequality there. Now, for 7 down here, I would ask you to give me an ordered pair that's a solution of this system. So let me show you how you would do it. I'll do 7 and I'll ask you to do 8. First of all, I just pick one of the easier ones here and I supply a value. So I need a y value that's greater than 0. I've picked 2. I need an x value that's less than 0. I've picked -1. I try both of those in this more complicated inequality here. So I try 5 times -1, and I ask myself, is that really less than or equal to 2 times 2? Well, 5 times -1 is -5. 2 times 2 is 4. So yes, it is. That means -1, 2 is an ordered pair that's a solution of the system, and that's all I was asked for, was just one ordered pair that is. So there's my answer, -1, 2. Do the same thing for 8. Hit the pause button. When you come back, we'll talk about it. Okay, I'm going to assume that you did that. I'm not going to give you a correct answer for this because there are so many. There are an infinite number, in fact, of different coordinates that would solve this this system of inequalities. So rather than do that, okay, I'm going to assume that you did that, and rather than, as I say, since there are an infinite number of solutions, sorry, I was just interrupted and hit the pause button. I'm not sure exactly where I left off, but I'm not going to give you an answer to 8. Instead, I'm going to move on to showing you how you can actually draw inequalities on a graphing calculator. So, previously I gave you y equals 3x minus 6 and y equals 3/4 x plus 3 as a linear system and taught you how to graph those on a graphing calculator. And it's essentially these same steps that you've already been doing. The big difference comes over here on the far left side of the screen of the calculator when you go to the y equals screen. So let me in fact show you what that looks like on the graphing calculator. Here I am at the y equals screen, and whoops, normally I would be, right there. Normally my cursor would be blinking right there. And to make this change right here, I'm going to use this cursor button to move left until I get there. Once that's blinking, I'm just going to keep hitting enter until I get the shape that I want. So let's go back and see what I wanted it to look like. It's like a kite flying to the upper right, or it's a triangle in the upper right corner. I keep hitting that enter button, and there's the shape I wanted. I want to do the same for the second one, but I remember it was supposed to be a triangle in the lower left, so I probably have to hit the enter button at least once more. Oh, and there it is. Okay, that's the shape I want. Now what I would do is I would type in the expressions for those boundary lines that I need for y1 and y2, and I would hit graph. And before I leave this screen, though, I want to make sure that I go back, and I also want to show you that you don't want to leave these in this state. So I'm just going to keep hitting enter, and eventually I'll wrap back around and come back to where I was. There I am for y2. I'll go back up for y1 and do the same thing. Nope, I went one too many. Anyway, I'll come back and do that later. I won't put you through that on the video. But I want to show you, if you've done this, if you set this up the way that it's represented here, that's the image you ought to see on your graphing calculator. If you don't, it's probably because your window's adjusted improperly. If you hit zoom 6, that will take you back to the standard settings for the window, and I happen to know that those will accommodate the shape that we're looking to see, and you should see something a lot like this. Alright, that's it for this lesson. Here's your homework on page 159. I hope you have a great weekend, and I'll look forward to talking to you about this when you come back.